Next question. Contact process is a case study. You use V2O5. Oh, hang on. They want the name. So formula is not going to cut it. If you forget the oxidation state of the vanadium, you are in very big trouble. Okay, this is vanadium plus 5. Vanadium 5 oxide is vanadium plus 5, oxygen minus 2. The oxidation state in Roman numeral matters a lot. It's really important for transition metal. Yeah. Next bit, you hear constant pressure, but temperature increase. You want to know the position of equilibrium. There's something called Le principle. You might not have heard this particular phrase, which is not important really, but you must know that when you want to answer questions involving equilibrium and equilibrium position, equilibrium yield, very likely you would have involved it at some point. We're talking about temperature here. So we see this reaction. It says that the forward reaction is exothermic because it's greater than 0, right? The delta H is greater than 0, see there? So what happened then is when you increasing temperature makes the equilibrium want to decrease temperature. So what is going on here? So Le principle says for a system in equilibrium, when you introduce a change, such as when you introduce a change to the system, which is the equilibrium, will try to go against the change. It will try to oppose the change. It will try to go opposite the change. You increase the temperature, the system, which is the equilibrium, you want to decrease temperature. Your reaction, your equilibrium, release heat. So how does your equilibrium going to decrease temperature if it release heat in this direction? By releasing less heat. Only then you can make the temperature go down. Okay, when you go in this direction and release heat, if you release less heat, that means you favor this side. Therefore, equilibrium position, because they want the position, right? Shift to the left. When you shift to the left, it favor backward reaction. Okay, next thing, you don't change temperature, you change pressure. Pressure affect gases, so you need to calculate. Well, have a look on the thing there first. Look for gases. 2 mole of gas, 1 mole of gas, 2 moles of gas. So gases matter, not solid, not liquid. So total of 3 moles of gases on the left side of the reaction, total of 2 moles of gas on the right side of the equation. So what does it mean? When you increase pressure, so increasing pressure will shift to the side, with lesser gaseous molecules, because the system wants to decrease the pressure, right? When you increase pressure, this equilibrium wants to reduce the pressure. It will shift to the side with lesser gaseous molecules, which is to the right. Therefore, equilibrium position shift to the right, meaning to say you favor forward reaction. Okay, next bit is quite straightforward. It's an energy profile diagram. You need to show reactants and product. This is on the left is the reactant, this on the right is the product. Enthalpy change you can label like this, and diffusion energy you can label like that. And then they told you that it's exothermic, so delta H is less than 0. So this is my reactant, H2S2O7 plus H2O. My reactant have lost energy to the surrounding. That's why the enthalpy change from the start to the end, from the reactant to the product, is a one-way arrow. Do not do double-headed arrow, doesn't make sense at all. So make sure you write the product as well. So there's delta H equal to the enthalpy change. Don't forget activation energy from the start, from the reactant level to the top of the hump of the reaction profile diagram. So there's activation energy. Pretty straightforward. Label, arrows. So from the start to the end, it's not double-headed arrow, so avoid double-headed arrow. Enthalpy change is from the start to the end. Okay. Next bit. You use air as a raw material in contact process. Name one other raw material used in the manufacture of sulfuric acid. So they've shown you one of the steps there. They've shown you another step there. So the first step before this involves burning sulfur. So before your stage 1 or step 1 involves sulfur solid plus O2 gas, give you SO2 gas. So you do actually need sulfur. Okay, raw material. One major use of sulfuric acid, well, you can use it to make car battery, for example. In fact, it is used as an electrolyte in car battery. There's also making detergents, fertilizer as well, etc. Okay. So next question is a dynamic equilibrium question. So with a definition of dynamic equilibrium, there are important factors to think about, okay? So you can catch my short tutorial videos specifically on covering on explaining equilibrium position and equilibrium yield based on changes in concentration, pressure, or temperature. So those have been labeled under A-level chemistry concept, but in reality, I put them as a playlist, and it involved the O-level concept as well. So the reasoning part, the explaining part is the same as O-level. The calculation part, that is the new thing that's in A-level, okay? So you can watch this video to update yourself on how I explain things fully, yeah? So at dynamic equilibrium, or under dynamic equilibrium, your rate of forward reaction, two things happen, yeah? The rate of forward and your backward reaction become equal. It is the rate that become equal, yeah? Or they equal each other. You need to be very careful, yeah? And then the second point, which a lot of people didn't get, is that the concentration of both the reactant and the product, basically everything, the concentration of the reactant and the product remain unchanged. Unchanged means they don't change anymore, or they remain constant. So that is the most important thing about dynamic equilibrium, okay? Because most people thought, oh, equal what? Equal rate of forward and backward reaction. The concentration of the reactant and product might be equal. I say might be equal, but not always. So what happens always is that their concentration is unchanged or constant once they reach dynamic equilibrium. Okay, so that's very important. Now they say that you keep the temperature constant, so there is not a change in temperature. This is your change, and the pressure is decreased. Pressure affects reaction involving gases. This is the only gas in this reaction because these are solid, okay? So you need to total up the number of mole of gas. There is 1 mole of gas on the right. Okay, on the right hand side of the equation, and no gases on the left. So gas will exert pressure more than solid. Gases have more pressure than solid. They exert more pressure than solid because of the arrangement of their particles. They expand in all directions, yeah? They occupy the volume of a container. So what happens next is, as pressure decreases, so this is what I meant by, you can watch my other video, my short tutorial videos that cover specifically on equilibrium and how to use Le Chatelier principle, which I'm going to use here. The principle is called Le Chatelier principle. Stating the principle is not important, but the idea is that for a system in equilibrium, if you have a change, if you introduce a change to a system equilibrium, the equilibrium will try to oppose the change. It will go against the change. It will try to go opposite the change. So pressure decreases, what will the equilibrium do? The equilibrium, meaning to say the system, meaning to say this reversible reaction, which is the system, which is the equilibrium, what will that try to do? That will try to oppose the change. And what is the change? It will try to increase the pressure because you decrease the pressure, so the equilibrium will try to increase the pressure. How would the equilibrium increase the pressure? You have 1 mole of gas on the right, no gas on the left. So when you have gases on the right, when you have more moles of gas on the right, it will shift to the side with more gaseous molecules. So the equilibrium will shift to the side with more gas molecule. Why? Because you want to increase pressure. That is what the equilibrium will do. Okay, and we already stated how many moles of gas on the right and on the left. There are more moles of gas on the right, therefore it will shift to the right based on what we just explained. However, be careful, they do not want position. These are what I meant by position, left and right, favor forward, favor backward. That is to do with position. They want composition, they want equilibrium mixture. They don't specify which one, so you have to include this, this, and this. Because it will shift to the side with more gaseous molecule, mean it will shift to the right. So I will get more CaO and more CO2. So we will get, or we will form more CaO solid, more CO2 gas, and we will have lesser of the reactant, which is lesser calcium carbonate. So in doing so, I haven't just stated the position, I have outlined each and individual one of their composition because they want the composition of the mixture. They don't specify whichever one, they just say of the mixture, which means each and every one of them. Okay, so now when you keep the pressure constant, so you're no longer changing pressure, but you increase the pressure, you increase the temperature. When you increase temperature, the equilibrium shift to the right hand side. Okay, so that is very typical. When you increase temperature, the equilibrium shift to the right hand side. That is typical for an endothermic reaction. So what does it mean? Well, that's what the conclusion is. Yeah, so the enthalpy change of the, you need to be very specific because this is how you explain it anyway. If you're asked to explain, is the forward reaction that is endothermic, meaning to say delta H is greater than 0. If we say the forward reaction it absorb heat, yeah, absorb heat. If we say the forward reaction is endo, that means it absorb heat from left to right, going in the forward sense, all right? So when you increase temperature, what would the equilibrium do? The equilibrium will try to decrease the temperature. How? The only thing the equilibrium know how to do in terms of temperature is to absorb heat. So to try and decrease temperature, the system, which is the equilibrium, will absorb more heat. It will absorb more heat. When it absorbs more heat, it will favor the forward reaction. When you favor forward reaction, well, that's what it says. It will shift to the right-hand side. Okay? For favor forward reaction means favor the right-hand side of the equilibrium.